All right, so welcome to my favorite part of this chapter. And so we'll start off by saying to improve something, it helps to know how it works, right? If you want to fix a car, you should probably know how a car works. If you want to make it faster, again, you should probably know how a car works. So how a reaction happens is what we call the reaction mechanism. Right, and that's my favorite part of chemistry is kind of studying reaction mechanisms. And if you take organic chemistry, a huge part of organic chemistry is reaction mechanisms. So let's take a look at this. So again, this is the how things happen. And so what we have to understand is that most chemical reactions are more than one step. So there are a series of steps, right? Step A, step B, step C, that kind of thing. So most reactions are greater than one step. But when we look at the chemical equation, we only see the overall reaction, not the individual steps. Right, so let's take a look at an example. So we'll go from ozone to oxygen. So we can take a look at the overall reaction, and the overall reaction is that two O3s, two ozones, get transformed into 3 oxygens. However, this does not happen in one step. There are multiple steps here. In this case, there's only 2. So let's take a look at these steps. So in the first step, this O3 falls apart into an O2 and a lone oxygen. And then in step 2, this O3, a different O3, reacts with this lone oxygen to form 2 O2s. And so so these individual steps are what are known as elementary reactions. So they are the individual steps of a reaction. And we can write rate laws based on the equation alone. We don't have to do any experiments because we know these are the elementary steps. Later on, we'll go from kind of the rate law to the elementary step, but we're still in the kind of intro phase here. So we can write rate laws based on just the equation. So here in this first elementary step, we see it's just one O3 reacting. And so we know that this rate is just going to be dependent on the concentration of O3. In this second step, we have to have an O3 collide with this oxygen by itself. And so we know that this rate is going to be dependent upon an O3 and an oxygen. And they're all to the first order because it's only one of them. You would have a second order rate law if you had kind of 2 O3s smashing into each other or something like that. And so just like in mathematics, we can sum these two equations to get our final product, and the things that show up on both the left and the right side cancel out with one another. And so this O cancels out with this O, and then we're back to our overall reaction, right? 2 O3s going to 3 O2s. But you'll notice here the intermediate is not shown. So while the overall reaction does tell you the overall process, it misses out some detail, right? It doesn't ever tell you that a single oxygen, a lone oxygen, is part of this reaction mechanism.